one more way to show that um, like most likely gives wrong results. One example, as I've said, like in this example the actual test is x, and if we take highest possible over here 0.5 in this timestamp and this time 0.5, this giving blank symbol, blank blank. After pre-processing everything like encoding decoding, we get single blank. But that is not the case because actually is ground to this x, so we want to predict x, right? So there is a high loss and less accuracy. So another way to look around this again is like another wrong example, like another case for giving wrong example is something like we are going to 0.5 because this is the highest probability in this timestamp, and this timestamp it's again 0.5, so that will be 0.5 into 0.5, 0.25 in terms of mathematics I'm going to show, prove. So, and again if you want to get x as an output, we need to find different encoding like patterns or paths or different ways of showing the encoding, like encoding alignments, different alignments. But for single dash or just only one encoding alignment is double dash, so that we can get single dash. But for x we have 3 and calculation has been done over here, and this is 0.5 to 0.2 earlier. So for example, now if we take 0.5 to 0.4, we get 0.2. So earlier we are going to get 0.24 for now, it will, but if we have changed this just for just an example, so we get 0.34. So 0.34 is greater than 0.25. So as you can see, with blank we are just getting less, but with the x we are getting more. So we are getting more probability, so we should look for that. And again, if we are getting more probability, so we can just predict it is an x itself. So because our alignments as made for x something like this, because we know the ground truth value is a training step. So if for prediction if we do like this, it is different, right? So as I've said, but we already know the probability of blank is just like 0.25 while it is 0.34 for x. However, the approximation algorithm often gives good result in practical situation. There are more advanced decoders such as beam search decoding, prefix search decoding, or token parsing, which also use information about language structure to improve the results. And again, like expected mean or expected averages, weighted averages, moving averages, those things are there. And we will be aware of the situation of the entire matrix for this particular term. Valid paths we'll see, that we'll see whether this comes in the alignment or not, it's valid, whether this particular word or in this particular timestamp, what is the probability score of that, whether it will come in the alignment of the valid paths or not, all those we will see. So those heuristic or those metrics also we can use, which we are going to see. So yeah, so best part decoding is of course only an approximation. It is easy to construct examples as we have shown, for which it gives wrong results, as we have shown one of the example based on training or prediction, both actually.